Today we are solving LeetCode 31, next permutation. This is one of those problems where brute force feels natural at first, but the real solution comes from observing the pattern carefully. The problem says, given an array of numbers, rearrange it into next lexicographically greater permutation. And if such a permutation does not exist, we must rearrange it into the lowest possible order, which means sorted ascending order. Also very important, we have to do this in place using only constant extra memory. So what is the problem? Problem is given an array of numbers. We need to rearrange it into next lexicographically higher order. This is our problem. And if no greater permutation exists, rearrange it into smallest permutation. And the condition is that we must modify numbers in place. We can't copy it into another array and then do the modification. We must modify in place. Okay, so let us understand what next permutation means. For example, if we have an array 1, 2, 3, then all the permutations in sorted order are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So the first one is the lowest permutation, the last one is the highest order permutation. So the next permutation after 1 to 3 is 1, 1, 3, 2. Similarly, the next after 3 to 1 does not exist because it is already the largest possible arrangement. So in that case, we return the smallest arrangement, that is 1, 2, 3. So what is the next permutation of 1, 1, 5? It will be 1, 5, 1. So the first easy solution is generate all permutations, sort them, find the current one, and return the next one. But this is not practical. If the array length is n, the number of permutations can be n factorial. And see, the array length can go till 100. So 100 factorial is a very huge number. So brute force is completely impossible. Also, the problem clearly asks us to do it in place with constant extra memory. So we need a smarter pattern-based approach. So brute force is this. Generate all permutations, sort them, find current one, and return the next one. But the time it takes is order of n factorial. If n is 100, then it becomes multiple 10 power, maybe 10 power 10 or 10 power 9. And the space is again order of 100 factorial because we need to store all of them to sort them. So this is simply not acceptable. Now let us think. When do we know that a permutation is the largest possible? Example is, how do we know 3, 2, 1 is largest possible? We see that all the numbers are in decreasing order. This array is sorted in decreasing order. That means no greater permutation is possible. So if we scan from the right side, as long as numbers are decreasing, that part is already at its maximum arrangement. For example, let's take this one, 1, 3, 5, 4, 2. From the right side, we see 5, 4 and 2. These are in decreasing order. So this suffix is already largest possible suffix. So to get the next permutation, we need to change something just before this decreasing suffix. That number is called the pivot. So in this case, pivot equals 3. So the key idea is from the right side, find the first index I such that nums I is less than nums I plus 1. This nums I is the pivot. Now let us take this example. Nums equal to 13542. We start from the right, compare 4 is greater than equal to 2, so it is decreasing. Then next number is 5, that is greater than equal to 4, that again is decreasing. And then we see 3. So 3 is less than 5, so we need to break. So we have got the pivot. 3 is our pivot. Why? Because the part after 3, which is 5, 4, 2, is already in decreasing order. This means we cannot make a bigger permutation by only changing the suffix. We need to increase the pivot slightly. Now, we need to replace the pivot with a number just bigger than it. The pivot is 3 and the suffix is pivot is 3 and suffix is 5, 4 and 2. Numbers greater than 3 are 5 and 4. To get the next permutation, we should not choose a much bigger number unnecessarily. We should choose the smallest number greater than pivot. Here that number is 4. Because the suffix is decreasing, we can simply scan from the right and find the first number greater than the pivot. So we swap 3 and 4. So what was the number before swapping? What was the array before swapping? It was 1, 3, 5, 4, 2. And after swapping, it becomes 1, 4, 5, 3, 2. So what we have done is we have swapped pivot and 4. Now we have increased the number slightly by replacing 3 with 4. But the suffix after 4 is 532. The suffix now is 5, 3, 2. Now as we can see that this suffix is still in decreasing order. Right? To get the next permutation, we need the smallest possible suffix. The smallest arrangement is ascending order. Since the suffix is decreasing, we can just reverse it. So suffix becomes, after reversing the suffix equals 235. Now this is the smallest possible suffix. So what is our final answer? Final answer is 1, 4, 2, 3, 5. So the complete algorithm is first scan from the right and find the first index I where nums I is less than nums I plus 1. This is the pivot. If no such index exists, the array is completely decreasing, meaning it is the largest permutation. So we reverse the whole array. So let me write the algorithm. So this is the algorithm. So find the pivot, first index from right where num size less than num size plus 1. If pivot does not exist, reverse the whole array. Otherwise, find first index j from the right where num j is greater than num size and swap num size and num j. And finally reverse the remaining the suffix. So let's write the pseudocode. That is very simple to write it. Pseudocode. This is our function. Next permutation nums. Now we initialize n equal to length of nums. Now we initialize I equal to n minus 2. So n minus 1 is the last number in the nums array. So we start with the second last number. Now while I is greater than 0 and the second condition is nums I is greater than equal to nums I plus 1. We keep on doing I minus minus, traversing backwards. And if I is greater than equal to 0, now after we have traversed and then we will check if I is greater than equal to 0, that means we have got the pivot. So we initialize the pivot equal to n minus, we initialize j equal to n minus 1, j is another variable, and we traverse in the backward direction. Finally, we swap the number. So basically, we need to find the number just greater than pivot. I is our, because I is greater than equal to 0, that means it is the whole array is not in decreasing order. That means I is the index of the pivot. Now we need to find the number which is just greater than this number at I position. So we initialize j equal to n minus 1, that is the last number of the array. And while this is less than equal to nums I, we keep on decreasing the index. So once we have got the first number that is just greater than the pivot, we swap the two numbers. Now finally we reverse the numbers from I plus 1 to n minus 1. That is the suffix part. We reverse the suffix. So in case I is equal to 0, then also we reverse the complete array. There is no pivot. So this is our pseudocode. Now let us compute the complexity. We scan from the right once to find the pivot. Then we scan from the right again once again to find the number just greater than pivot. And finally we reverse the array. Reversing it takes again order of n time. So we do uh, three different things that and all of them are done in sequence, and all of them takes order of n time. So the complete time complexity is order of n, and we are modifying the array in place. So no extra variable is required. So space complexity is simply order of 1. Now let's write the code, the Python code. Let me comment this out. So n equal to len nums. Then step 1 is find the pivot. I equal to n minus 2, and the same loop that we wrote in pseudocode. Then the second step is if pivot exists, then find the element just greater than pivot. Now the step third is we need to reverse the suffix. So for reversing, we initialize two variables, left equal to I plus 1 and right equal to n minus 1. And while left is less than right, we keep on swapping them. So this is our code. Now let's try to dry run one example. Let's say this is our nums equal to 13542. So we start from index equal to n minus 2. Step 1 is find pivot. So 4 is greater than equal to 2, 4 greater than equal to 2, 5 greater than equal to 2, 5 greater than equal to 4, we check the adjacent numbers. Now 3 is less than 5, so 3 is our pivot. Pivot equal to 3. Now step 2 is find the first number greater than pivot from the right. So 2 is less than equal to 3. Then 4 is greater than 3 and 4 is the number that we want to swap with. So we will swap 3 and 4. So array becomes this. Now we need to, step 3 is reverse the suffix. So the suffix is our 532. We will reverse it and it will become 235 and thus our final answer becomes 14235. So it works for the example. Let's try to run the test cases. Let me first comment this out. Okay, so the test cases pass. Now let us submit and see if all the cases passes or not. And yes, the solution is accepted. So what what did we learn from this problem? First, we learned how lexicographical ordering works. Second, we learned what the next permutation that the next permutation is not about randomly rearranging numbers. It is about making the smallest possible increase. Third, we learned the importance of scanning from the right side. Fourth, we learned that a decreasing suffix is already the maximum possible arrangement. And finally, we learned that reversing this suffix gives us the minimum possible arrangement after increasing the pivot. That is the whole beauty of the problem. So this is our key learnings. Now finally look at the common mistakes that we make in solving these problems. So first is sorting suffix instead of reversing. That is a very common mistake. Sorting works but reversing is better because we already know the suffix is decreasing. The second mistake is finding the wrong pivot. Remember, pivot is the first index from the right where nums I is less than nums I plus 1, not less than or equal to, strictly less. The third mistake is finding the replacement from the left. We should scan from the right to find the first number greater than the pivot. The fourth mistake is forgetting the completely decreasing case, like 3 to 1. In this case, we simply reverse the whole array. The fifth mistake is returning a new array. So LeetCode expects us to modify the input array in place. So the complete idea is simple. Find the first place from the right where the increasing possibility exists. Swap that number with the smallest number greater than it. Then make the remaining suffix as small as possible by reversing it. That is how we get the next permutation in order n time and order 1 space, constant space. This problem looks tricky, but once we understand the decreasing suffix idea, the whole solution becomes very natural.